climate, we tend to think of large-scale areas because we're, as living things go, reasonably large, and we're affected by big patterns. We want to know if it's going to be rainy tomorrow. We need to look at what the weather's doing today some distance away. But we also have climate variation on much smaller scales. And this is especially important for much smaller organisms. So these variations are referred to as microclimates. Just a little bit of difference in how steep or flat a slope area may be. A little bit higher, a little bit lower. What direction the slope is facing? Does it tend to be into the sunshine or to the shade? Wind patterns. These will provide very small scale variation in the climate, the typical temperature, humidity, amount of sunshine, all these types of things. And so what a particular thing is experiencing is not necessarily what the weatherman would suggest. It's what's happening right in its local microclimate. So for example, the weather forecast says it's going to be sunny and say 33 Celsius, pretty warm out there. But that's not what something that lives in the woods in deep shade is going to experience. It's going to be somewhat cooler. So we're going to see these variations in the microclimate. There are ways you can try to actually affect your local climate. Of course, we do this with stuff like air conditioning, but other types of life. So for example, in a forest, already talked about shade. Trees also are blocking wind, and so we have air that's more still in the forest. And of course, how that affects things, well, it depends. For example, in winter, blocking that cold winter wind, that might feel nice down in the forest. Also, plants, again, they don't have any sort of pump like a heart. Instead, they're relying on evapotranspiration. Water evaporates out from the tips at the leaves, tips of shoots, that sort of thing. And as that water evaporates, the water behind is pulled, and the water behind that pulled. This works if you have a narrow enough tube. That's why water will soak up into, say, a paper towel. It's going up into the little tiny spaces between the paper fibers there. And this is what actually brings water up all the way from down in the roots to the top of even a big tree. And along with it, bringing the minerals, other things from the roots, flowing up through the xylem, as opposed to going down through the phloem, bringing the nutrients from the leaves. But for that to work, that tree has to be evaporating lots of water all the time. Evaporation, as you've probably noticed when you sweat, does cool things off, at least if the sweat evaporates. So evapotranspiration helps keep forests cooler than they would otherwise be. Or if you're an animal, you can move around. Living in hot areas like a desert, well, if you dig down, you can, instead of being in the hot sun, you can get a little under the dirt, down to where it's not heated up so much, and a little cooler, and then come out at night. Conversely, if the weather's very cold, digging down a little bit into the dirt will give you a spot that doesn't get quite so cold, and you'll stay somewhat warmer down there. Fire plays an important role in many ecosystems. Stuff that was present that gets burned, that releases the nutrients that were present in there. So the ashes from fire can be useful as fertilizer under certain conditions. Takes away plants, exposes the soil. Now you've got sunshine and seeds that were in the soil may have a chance to grow that didn't before. Soil can erode without the roots helping hold it in place. Generally, actually being burned is not good for you, whatever type of life you are. However, there are some types of plants that really like these burn conditions, and the seeds actually are not released from the plant until burning happens. For example, there's some types of pines where the pine cone stays tightly shut until it encounters the heat of fire. That fire has cleared out the other stuff and made a good place for it to grow. There are actually some animals that are attracted by heat or smoke, whether they like to eat these types of plants that grow after fire, or a damaged plant from fire, or other factors that actually document. There are some types of predatory birds in Australia that where there's a grass fire, they'll actually pick up burning sticks or bits of grass and then drop them someplace else to spread the fire. And they are doing that because fire, okay, all the little insects and rodents and things start running away from it. And they're running away from the fire and not watching out as much for that predatory bird. So it's a way of getting prey there. Now, Smokey the Bear, tend to think of fire as a bad thing, but it depends on the setting. Some natural habitats, such as most grassland areas, or savanna, where you have grass and trees, chaparral, kind of patchy bush type areas. Some types of pine forests, like the longleaf pines here in North Carolina. These are ecosystems where fire is a normal part. And so the plants, animals living there are adapted to it. And in fact, if we keep them from burning, then the native species tend to die out. A lot of the species that depend on these settings are somewhat endangered because we've stopped fire and also because we've turned the habitat into farm fields and houses and stuff like that. Now, other ecosystems don't usually have much fire, and burning there can be a problem, and certainly too much burning, even in these places, is not good. The trick is determining what the natural level, the normal sort of fire disturbance would be, and trying to maintain that rather than too much or too little. If we block fire from happening in a place where it normally would, then this means we're getting a lot of the dead wood and leaves and things that otherwise would be burning more frequently piled up. When the fire finally does succeed, it's a lot worse. There's a lot more fuel there. Not only does it help the fire to spread, it also tends to mean that fire is going to be hotter and more damaging than if there was just a little stuff there. And we're changing the ecosystem. Without that disturbance, plants that don't like the fire can grow in there. So what would be a grassland with the fire may start to get trees growing in. Trees that like fire will have trouble competing with the ones that are more sensitive to fire coming in without it. So we see problems there. And so controlled burning is the term used for the approach to carefully planning, burning an area that should normally burn naturally in order to maintain the native plants and animals in their proper conditions. But again, we need to be careful, figure out what is actually the natural pattern there. I've heard of cases where people trying to maintain a natural area, over there, 2 states away, there's the pattern they use for burning. All right, we'll do that. Our native things are not doing well. Oh yeah, 2 states away is somewhat different. That wasn't the normal burn pattern that would naturally occur in your area. So, just because one habitat normally has burning, that doesn't mean it's going to be the same pattern as another. Of course, also this does suggest that sticking your house in the middle of a habitat that frequently burns is not such a good thing. We've seen a lot of problems with that in California over the past few years. Here's an example. You see the person there, safety gear, watching the progress of the fire for the controlled burn in this area.